let's look at a couple more examples. I chose this next problem because it's got kind of a trick happening in it. We've got the first term with a single decimal place, this term with 2 decimal places. So the multiple, or the power of 10 that we're going to need to multiply by in order to get that decimal to clear is a 100. But there's kind of a hidden term in here. We're going to multiply the 100 times the 2/10 n, but because this negative is getting distributed over the n and the 4, there is actually an invisible 1 there that needs to get multiplied by 100 as well. Because I talked before about you not needing to multiply the terms that are inside the parentheses, since the parentheses, since they will end up getting 100 times bigger when the coefficient out front carries through. So we do have to make sure that we recognize that this negative does include a coefficient of 1 that needs to be multiplied by 100. So this problem will look like this. When we take 100 times 2/10, we get 20n minus 100 times the quantity n plus 4, and on the other side, a 16. Multiplying the negative 100 through, I'll get negative 100n minus 400, and combining like terms, a negative 80n minus 400, and then adding 400 to both sides leaves me with negative 80n equals 416. Now in the past, when I divided by negative 80, I just reduced the fraction to get my final version of n, but this is a decimal problem, so I want my answer to be in decimal form. So I'm going to go ahead and use my calculator to make this quicker and take 416 and divide it by 80 to get a decimal answer of 5.2. But the 80 I'm dividing by is actually a negative 80, so my answer is negative 5.2, or 5 2/10. Substituting that value into the original equation, I get 0.2 times a negative 5.2 minus a negative 5.2 plus 4 should equal 1600ths. So I'm going to do the math that's inside the parentheses here first. When I take 4 away from 5.2, I end up with a negative 1.2. And I'll recopy the rest. Doing the multiplication next, 2 times 5.2 would be 10.4, but since there's a decimal place, it's going to move my decimal place in my answer one spot too, so instead of the decimal going here between the 0 and the 4, it's going to bump back here and go between the 1 and the 0. You're also free to do these calculations on a calculator when you're doing your check. This minus a negative, we'll turn that into plus 1.2. Oh, and it looks like I dropped a negative sign here too. I was multiplying by negative 5.2, so that's going to be negative 1.4. When I add a negative and a positive number, I find the difference between them, and the difference between $1.04 and $1.20 is 16 cents. And this was my bigger number, so that answer is going to be positive. And sure enough, that is the value I started with on the other side. So this problem checks.